Hi, John. Good evening. Bonsoir, everybody. And
Hi,
welcome to the
Cristiano.
fifth episode of the NeuroTechX Showcase. Hey, John. How are you today?
I'm excellent, thanks, Chris. How are you? Welcome, everyone, once again.
Yeah, welcome, everyone. I'm good. I'm so excited by this episode tonight. It's about music and the influence of music on the brain. What's your personal experience with music, John?
Oh, personal experience. I mean, I'm a amateur musician of the kind of jazz blues variety, and yeah, I've been mucking around on various instruments like keys, piano, bass, for probably 20 years. But not in a professional context. So I certainly, as a cognitive neuroscientist, like there's a lot of interesting cognitive neuroscience around. Well, I should actually, to be honest, like I also used to work in language. So I work a little bit in language, and
There
particularly
you go.
auditory language. So there's an
Hmm.
interesting overlap between music and some of the rhythmic aspects of speech and language. Essentially, there's a lot of rhythm
Yeah,
in
the
speech,
perception of
prosody,
features,
and
right?
there are cues that are to do with well, actually, not to go too much into language, but interesting point. Everything about language is about kind of statistical regularities at
Yep.
different time scales. So you have like statistical and I mean like auditory language, right? So it's
Hmm.
like phonemes and morphemes, like the little tiny sounds that you make. Those are, when you actually look at their spectrum, they have a certain statistical structure, and then you build it out to parts of words, sets of words like phrases, and you get towards things that are really getting towards music, right? It's like kind of
Definitely.
groups of words, groups of sentences that will have some kind of both like a rhythmic structure, but also a kind of thematic structure that evolves, right?
Yeah. And that's part of the
So yeah,
perceptual aspects, right? Well, the music has a perceptual aspect, like language has a perception aspect, but also there is a psychological
yeah,
aspect of music, or if you like, language, and that speaks more about emotional aspects in the perception of music. And I know that you know music has been well known and well documented in wellness and in music therapy. So there is an aspect to that is perception, but there is an aspect that is more psychological, if you want, holistic, and has to do with music therapy. And we'll speak about that during the evening. And this definitely has touches
I
upon
would say that's
also,
one of
you know,
the
go
really
on.
fascinating things about music is how it can really be like an arrow into the heart. Like it sounds, but it's curious like how directly you can get someone's the hair on the back of someone's hands, and they kind of get to the like an emotional with just sounds, right? Just a kind of relatively simple and brief auditory stimulus. There's not that many other things, or if anything else, in the perceptual repertoire that can get to an emotional effect quite as quickly,
Definitely.
and that's fascinating.
It's fascinating. You can measure it both on the side of the music and on the side of the brain, right? You have two correlates that are, going on in parallel pathways, if you want, conceptual
Yeah,
pathways, unified pathways. And there is this concept of music informatics that analyzes the features of music, right? But you can also combine it with the feature of the brain and how the brain reacts while concomitantly with the, delivery of music content. So we'll touch upon that and how, artificial intelligence can be used to find the correlations between the two streams and how you can leverage that to make music a better experience or to make, something out of, wellness with music. So we'll touch upon that. So the guest of tonight's guest is Frank Russo. He's the Ansar Sonova Senior Industrial Research Chair here in Toronto, and he's a professor of psychology at Ryerson University, which is not far away from here. I can walk there in 10 minutes. And we are honored to have him today speaking about his work. He's also Chief Science Officer for Lucid, which is a company that uses AI, like we're talking, to unlock the potential of music as wellness and therapy. So we'll talk about Frank's latest development. He has been doing so much in so many fields, so we get to know from him what he does. But before doing that, I'd like to give a bit of an overview about NeuroTechX. What do you think, John?
Let's do it. Let's do it. There's always a lot to talk about, but it's worth revisiting and reminding as well.
Definitely. So I'm loading my site here. Let me share my screen. So I'm pointing out this site is neurotechx.com. This is our association, our institution, and we want to have a look at the numbers. The community is a global community that to now reaches up to 17K members all over the world. NeuroTechX pillars are founded on community, education, and networking. So we do have a section also for professional development and a job section in this site, and I recommend you to have a look. I will point it out in a second. And before doing that, under this map here, we do have a button to join our Slack channel. It's free. You can join us and follow all the conversations. Among others, we have a section where we sell hardware, third-party hardware at cost. So you can have a look at that. And this is, in my opinion, the most important section, which is about career opportunities. So either you are a job giver or you're looking for new opportunities, you can interact with this and interact with the team and then post your advertisement or look for a job all over the world. So this was the short spiel. So I would like to invite Frank on video. And let's do that. It's connecting.
So, Chris, you think 10 minutes to Ryerson from your place?
Not even.
You basically live at Ryerson University, don't you? Yeah.
Yeah, I go to Balzac for my coffee. It's on campus.
Balzac, yeah, it's a nice Balzac. I like to go ice skating there in the winter. It's something. I've been in Canada 7 years, and I bought my first pair of ice skates last year.
I know that
as a kind of like winter pandemic, crisis thing, because I messaged him. I was like, "Hey, come skating with me. Hey, come get a coffee with me." But they have a rink down at the Balzacs near the in Ryerson. They have a rink around Queen's Park, and it's a really cool kind of winter thing that you can do in Toronto, because you have these like public places you can just go and skate and fail to skate, as I largely do at the moment.
Yeah, now it's a park. It's a nice park there, Ryerson, and actually Balzac is wonderful coffee. I recommend that.
Yeah.
So we have Frank about to connect. Let's wait another 2 seconds.
Well, I'll carry going on about the ice rink at Ryerson. So I was on the ice rink at Ryerson until I think I must have been the last person to use it this year, because I turned up when it was basically melted, but you wouldn't know from looking at it. I kind of turned up with my boots on, stumbled over, and then I was like, okay, it's a bit slushy, and then tried to propel, and then it's like, it's like slush and ice everywhere. I'm like, okay, there's no more skating happening this year. It was the end.
Oh, we'll see. I think they fill it with ice, in January.
Yeah, I think so. So I'll be there.
So Frank is about to connect. Meanwhile, I want to mention the aspect that music is also important for Me, I'm a musician myself. Hi, Frank.
Hi, Chris. Hi, John.
We're talking about music.
Hi, Frank.
Uh, Good to meet you. Yeah, and I understand you were also talking about ice skating on Lake Devo at Ryerson. It's a favorite place of mine as well.
Do you ice
It's,
skate?
Right.
oh yeah, I have a
Lake Devo. I
long.
didn't know that was sort of.
Yeah, I think that it was the Devonshire Society, some sort of um, maybe social
Oh,
club at Ryerson. In the early days, and they nicknamed it Lake Devo, and the name has stuck. So my students and I are often uh, on that rink at lunchtime doing pickup hockey. So
all right.
I still play hockey. I play in the intramural league at Ryerson. It's pre
Oh,
COVID times. It's a fun thing to do.
and the ice rink is, I guess, it's not Lake
I
Devo.
think that's on my trajectory somewhere.
Yes.
Once I'm not rubbish at skating, I'll consider learning to play hockey. I probably shouldn't do
You
it the other way around.
Oh, I don't know. Yeah, there's people on my team that are probably where you are. So
If you're good at
Right,
shooting,
just
John,
to
it
right.
should be fine.
yeah, or goalie, or you seem like a big guy, so you could just hang around in front of the net to distract the
I,
offensive
I could
players.
probably do that.
Yeah.
Yep. Yep.
Frank, we were introducing your fantastic work with the Lucid project. Would you like to introduce it for the audience?
I certainly can. So I am going to present some of the work with Lucid, but just to give a high level overview, Lucid is a project that has developed considerable momentum over the last 3 years. It is originally a Ryerson startup, and the students have really taken it a long way, and the founders have got some good funding behind them, and I think it's fair to call the company a post-revenue company now. There are
Hmm.
clients, there are new opportunities. So essentially, what the project is about is steering music so that it serves as a kind of medicine. Can we use music strategically in order to bring us from, let's say, a state of anxiety to a state of calm? The answer, of course, is yes. Like we all do that in our own informal way. But Lucid is trying to optimize the process by taking a page from music psychology, a page from music therapy. There's quite a bit of AI in the system. So
That's
those are the
understood.
kinds of threads that we're pulling on.
So that's interesting. Maybe if I understand well, and correct me if I'm wrong, but what you're trying to do is the equivalent, the high tech equivalent of when I go to my Spotify
Exactly.
playlist and I come up with my own playlist that makes my day. But you do it in a more systematic way, right?
I hope so. That's our claim, and I think we've got some evidence to suggest that we're a little more effective than just a generic playlist. So there's some customization involved. There's some psychological principles involved. There's a few different technologies that are all bundled together that I believe are making that Spotify playlist uh, a gold standard Spotify playlist. Much more effective than what you've intuitively put together.
Thanks, Frank. We're looking forward to have a look and see at your presentation and your business model.
I don't have a pitch deck or anything, but I'll tell you a little bit
Feel
about
free.
our approach and some of the outcomes. Absolutely. So I know a little bit about Chris's day job. I know the companies that he represents. I don't know too much about you, John. What are you up to?
Yeah, sure. I'm a scientist, research scientist at CAMH, Center for Addiction and Mental Health
Ah, yeah,
in Toronto. So
yeah,
just around the corner from you. Also an assistant
yeah.
professor at University of Toronto. So I have a fantastic research team, about 7 grad students and some postdocs and RAs. And what we do is how I like to describe it is the intersection of neuroimaging and computational neuroscience. So my general scientific background is neuroimaging, or at least it was for a long time, and then more recently computational neuroscience. But what we really are physiological modeling, understanding of physiology to do a better job of understanding the things that we can measure with human neuroimaging principally, so EEG, fMRI, etc., and also in particular brain stimulation. So a lot of people in the group are interested in working on understanding the physiology of various kinds of brain stimulation and doing some experimental work as well.
Great.
That's us in a nutshell.
Thank you. Yeah, we've played a little bit with brain stimulation in my lab. We've been looking at transcranial random noise stimulation and alternating current stimulation for manipulating emotional responses. But we don't have much depth there. There's one PhD student that is pushing that work forward. Sorry, just a second.
That sounds like a pretty interesting combination.
Yeah.
And that one you mentioned, TRNS, that's the I don't know, the black sheep or something of the electrical stimulation family. It's like,
okay,
people who are in the know about that one.
Yeah. Okay.
Why is that the case?
Well, it's the main two on the electrical stimulation, which is now TACS and TDCS, alternating current and direct current. And RNS is also an alternating current of some kind, but it's kind of based on some different principles, but essentially the same gear.
And is the black sheep because it's more invasive, or because it's a younger science?
It's just not known, not as well known. As a bit of a kind of wild card.
Mm-hmm. Understood. Frank, I know that you.
Go ahead.
Sorry, go ahead. I didn't want to interrupt you.
Yeah, as I recall, we started with TRNS because there was some provocative paper in a psychological science paper showing modulation of emotion perception after a brief TRNS stimulation, and we had some ideas about how to get what we wanted by using TACS. We wanted to enhance endogenous rhythms in the alpha range in Broca's area, and we had some theoretical guesses as to why that might be helpful for what we were after. But then we saw this paper that got the kind of effects that we were after with TRNS, and we started there, and we did get a similar result. The work got halted by the pandemic, but I look forward to getting back to it.
Looking forward to see the result.
Okay, so I'm gonna jump on Broca's area there and kind of pick up something I was just riffing on when we kicked off the call, which is this intersection of language and music, right? And from the point of view of psychology, cognitive neuroscience, and of course, like how the brain works. I mean, interesting that you say Broca's area for emotion, but I think in general, from the structure, like language per se, one of the functions that Broca's area tends to be contributing to is this kind of like syntax, right? Syntactic structure and little short-term memory aspects. So how does that fit in with the music?
Well, it wasn't a music study. Like, a big piece of our work is emotion perception, and Broca's area is implicated in emotion perception. So there are two basic systems that seem to respond to facial and vocal emotion, and one of them is some kind of embodied response, some sort of mapping of perception onto action. And that's where Broca's area comes in, among other areas.
Right.
And then the other system is a little more cognitive, theory of mind kind of stuff involving the default mode.
Right.
So, yeah.
There's a lot of this Broca Area is a hub, you know, on the left hemisphere for right-handed people that is, you know, theoretized to account for, you know, language production. It's potentially also connected with many other areas at the emotional level, at the default mode network level, and it's probably what you're measuring there is the gateway to all those functions in the brain.
For me, so this is it's a little bit of a tangent, but I see it as the gateway to mapping perception onto action.
Right.
Yeah. So that's the reason that we're
Interesting.
interested in.
Is there a psychology model?
That's the reason that. So if you look at just the basic speech network, you know, if things are really clear, the person is loud, there's no background noise, you can process speech using the auditory cortex alone, primary and secondary auditory areas. You do just fine. But as soon as you introduce a little noise, this other aspect of the speech network kicks in, and that's the caudal parts of what's come to be known as Broca's area. And then when we get even noisier, that's not enough. Like, it's not enough to listen to the speech and then to simulate the speech so that we have this motor input. But now you also need to be using short-term auditory memory. You need to be using the frontoparietal attention network to tune out all the distractions and focus on only the thing that we're interested in. So, yeah, I think it's a business of, we've got circuits that do their thing in good conditions, and when they don't work, all these other circuits kick in to try to get the job done.
Is that fantastic on this overview about how the brain can be attuned to different environmental conditions and how adaptable it is to change and switch gear and then activate different networks. So probably emotions are also involved in that. Is there an emotion network? Could we qualify that as a network, or it's a holistic model?
Yeah, network's a fuzzy term, but there's certainly a group of structures that's implicated when we're trying to identify or read emotion. And there seems to be two basic networks. One is something akin to the mirror neuron system. So it's a mapping of, despite all the baggage with that system, I think when you look at the structures involved, that's what it is. So it's a mapping of perception onto action. And then the other system involves cognitive empathy. So trying to relate all of the contextual variables to your own life experience.
Valence?
And valence is involved in both of those. So it's not like valence is processed by the first network and arousal is processed by the second. I think they're both dealt with. The first network is the main network, I believe, that is engaged. And I think when things are challenging, we use the other network.
Understood.
I also think that some people no longer have access to that primary network. So if you've got a hearing impairment, if you've got Parkinson's disease, if you've got damage to the sensory or the motor side of the basic mapping of sensation onto action, then you can't use that standard method for reading emotion. You have to rely on a more cognitive kind of empathy to read.
That's why music is so important. I think music is such an interesting topic because it seems to be that unifying glue that taps into all those functions. And it was dealt with, for example, in a book from Oliver Sacks, Musicophilia, that probably you know. And he also had a lot of patients he was a clinician, and he had patients from Parkinson's disease, patients from autism, and then dementia patients. And he was telling about how music could create that context to unify all these network, if you like, all these functions. That's very interesting.
Yeah. It occurs to me that, I'm mindful of the schedule, and your cue to me to talk about Lucid was your cue to me to roll my presentation. So I'm going to, if it's okay with you, I'm going to do that.
Please go ahead.
Yeah? Okay, so I'm just going to ramble on about the kind of work we're doing in this specific project for about 30 minutes.
We're looking forward to that.
Okay, and if there are questions, I am happy to take them, and I'll try to stay on track. Okay. Okay, so I'm a professor of psychology at Ryerson. I'm also the chief science officer for Lucid. Lucid is the aspect of our work that I'm going to focus on in this presentation. I could speak more broadly about the work that we do in the Smart Lab in my lab later in the question period. But broadly, the lab is engaged in research concerning music, speech, and hearing. And the Lucid work very much focuses on music and its capacity to serve as a kind of medicine. So I'm often asked by students, do you consider music a medicine? And I often give a qualified kind of response. It certainly depends. I think often the effectiveness of music as an intervention can't be thought of as a medicine. I think often, in order to really pull the power out of music, you have to engage with it as a kind of exercise. So thinking of it as more of a program or an intervention program makes a little more sense. But certainly there are uses of music that qualify as a medicine, where and the one that we've focused on quite a bit at Lucid, I think is the most emblematic of that, and that's taking someone who's in a stressed, anxious state and bringing them to calm. So it's the kind of thing that many of us do intuitively. We have our own favorite playlists to do this, and we're trying to optimize the process. So I should say that I'm at Ryerson, and you may know, if you're in the Toronto area, that that Ryerson is having a bit of an existential moment right now, and we are no longer Ryerson. And many people are referring to Ryerson as X-University now, and I'm one of the faculty that signed that initial petition, which was one of the catalysts to making this name change. So it was a complicated journey. I think a lot of us feel attached to the name, and I myself saw merit in Egerton Ryerson's life. And I guess I've come to be educated about some of the damage that he's done, and I see the hurt that exists, and I think collectively the community sees that it's time to move on. So we're in the midst of this name change. So again, what I'm talking about is functional music for emotion regulation, and the way that we're doing that is that we're taking this transdisciplinary approach. We're pulling elements of music therapy, music psychology, and music informatics, and we bundle all this in what we refer to as an effective music recommendation system. So it's some automized system that serves up a playlist that should create this functional music outcome. So the general approach to how we do this is, so Chris was asking me about valence earlier.
Hmm.
So that's a nice foreshadowing to what I'm about to talk about. We take a dimensional model of emotion. So what that means, you see the image on the screen here, is
Yep.
that there's emotion in two dimensions. We have valence on the x-axis, and you can think of that as positive emotions on the right and negative emotions on the left. And arousal is on the y-axis. So
Hmm.
we get into higher energy states. The higher up we go, lower energy states, sleepiness, the lower we go. So what we have the user do is we have them tell us how they're feeling right now. So at the moment, if I was to label how I'm feeling right now, I would say what seems appropriate. I guess I feel moderately aroused and positive. So I'm in the convinced area of that spectrum. So it's a little bit positive and a little bit high in arousal. So maybe that's my starting point, but maybe after this podcast, I don't want to be in that state. I want to move to a relaxed state that's going to prepare me for bedtime. So we have the user select their current emotion and we ask them to give us their target emotion. And basically we create this trajectory. And the way that we're doing this is by working with an AI that has been trained to label new pieces of emotion with these arousal and valence characteristics. So we can either create new music and label it automatically, or we can read in music from your own playlist. Like we don't have to have seen the music before. We could take all of your music and process it through our algorithms, and we can come up with this kind of space of emotion, and then we can map out a playlist. I'll say a little bit more about how the playlist is generated. It's not canned. It is generated through AI. So as I say, input to the system requires that the arousal and valence of the current mood state is input by the user. It can also be inferred from biometrics. So we've done some of this in our past work through peripheral physiological measures. We're also working currently on looking at EEG as an input to the system. We've also been working with wearables, and my lab has a fair amount of experience with FNIRS, so that's another option for us. I'll say a little bit about those options going forward.
That's cool.
Yeah. I'm going to get into a little bit of these details, but from EEG very quickly, you know, your audience might be aware that many people have been trying to use band power analysis in order to gauge people's arousal levels. So it's a very common use of EEG, and that's something that we're doing as well. So you can look at different ratios like the theta alpha ratio. And valence, a good reading of valence can come from frontocortical alpha lateralization. So what we tend to see is more desynchronization of alpha in the left frontal areas when people are feeling positively valenced.
And that's generally valid for right-handed people.
You know, I think that it's certainly, I don't know to what extent handedness comes into that. That's a fair question. I don't think that that's well understood. You know, it's certainly not something like language where we see it flipped for people that are left-handed. So the output of the system is, regardless of what kind of input we put into the system, like the standard input, and like there is a commercial system right now, the standard input is simply having people indicate their current mood state and their target mood state. So we've got machine learning models that as I say, predict arousal and valence from a music library that already exists or one that you input as the user. And the way that we do this is by breaking down the music into MIR features. So MIR stands for music informatics retrieval or music informatics research. And it's a bunch of acoustic variables that we can represent as data and that we can perform machine learning and data science tricks with. So as an example, I might be interested in the proportion of energy in the signal that's low frequency, or the proportion of energy in the signal that's high frequency. That would be a type of MIR feature. I could look at the roughness in the signal, the acoustical roughness. That would be another kind of feature. So the Lucid system selects tracks from these libraries to generate the functional sequence. A critical aspect of our approach is that we have created this AI based on empirical ratings. So we don't use expert tagged databases. We use large cohorts of participants that are evaluating arousal and valence in music, and we train our AI based on that. There are lots of big MIR data sets out there that are fairly meaningless in my view, because they're tagged by one expert and they're not very robust. So the other important aspect,
I have a quick question. Yeah, quick question. You know, Richard Waltman from the audience remarks that MIR feature extraction is hard work, and I would like to add on top of that you know, as regardless of how extensive is your labeling in terms of population, people labeling your features, there is always going to be a bias, and
absolutely.
And then maybe how do you deal with that?
By characterizing the user, by getting a sense of their listener preferences. So the system is customized, and I'll get to that a little bit further. And some of our future research directions are to further improve that customization. So
thank you.
That's the general approach. Good point, though. Yeah, there are cultural differences, there are subcultures, and that's going to affect the emotional reading on any excerpt of music for sure.
Understood.
So another important aspect of our approach, and this is a bit of an assumption, but we think it's an important one, is we've borrowed a page from music therapy. And one of the things that music therapy students come away with when they're learning how to manage mood of the client. Music therapy is many things. It could involve helping people get in touch with their with tension in their body. It could involve people working through traumatic memories. That's not what I'm referring to here. But when a music therapist is trying to change the mood of a client, what they're taught is that you need to apply the ISO principle. You need to meet the client where they are, and then you'll guide them to where you want them to be. So that's the approach that we're taking here in the way that we steer the system.
An ISO principle is in terms of guidelines, ISO guidelines?
No, it's not ISO, like international standards or anything like. The ISO comes from ISO for equal. So if you are feeling tension, I should meet you with tension. If I try to fix your tension with relaxation, the theory is that you'll block it out. You don't want to have anything to do with it. So that's why we take both the current mood of the user as well as their target mood, because we start them with music that matches their own mood, and we slowly bring them to where they want to be.
That's very clear. Thank you, Frank.
Yeah. And we're trying, we do have a system that works, and I'll give you some empirical evidence, but we're busy tearing the system apart to see what aspects are really critical and in what instances and for what kinds of users. So we're not married to any of this, but I'm giving you the lay of the land, the current approach that we're taking.
Fantastic.
So this is more beta, like in development now, not beta for beta band power, but work that we're trying to do behind the scenes in order to steer the system using a kind of brain-computer interface. I thought that this might be of interest to your, the nature of your podcast.
Very much so.
So I've kind of described the system that we're looking at band power ratios in theta and alpha band to characterize arousal, and we're looking at the lateralization of activity in order to characterize the valence. I don't think this system would be robust enough on its own to steer the entire system. I think where it does become useful is in steering when the system has gone wrong. So if we continue to sample from the user's brain and things are clearly going in a bad direction, this ends up becoming a very useful instrument. You kind of kill the whole mood effect of the music if you're continually bothering the user to ask them, well, how are you feeling right now? How are you feeling right now? So our intention is to use biometrics, brain-based interfaces in order to steer the system in more of a subtle way. So you can do similar things with hemodynamic responses. So we've got a good amount of experience in working with FNIRS signals in the lab now. We've got a few published papers, a few more in the pipe. And with Lucid, we're just starting to think about how we could use FNIRS for reading emotion. And the principles are kind of similar. This is taken from a study in Frontiers in Human Neuroscience by a group in China. And they're also finding that they see more lateralization of activity with more positively valenced moods and changes in the overall amount of prefrontal activity with higher levels of arousal.
I believe the FNIRS signal is the difference between oxygenation and deoxygenation, right? So
there's many metrics you can use with FNIRS, and I'm happy to unpack it a bit. So basically, you put two sources of light through the scalp, and the absorption of those different wavelengths of light give you a read on the extent to which the blood is oxygenated or deoxygenated. So oxygenated blood, we can take as activation. Deoxygenated blood, having less deoxygenated blood, people may also interpret as activation. So what some people do is they take the difference between the two. So oxygenated, oxy minus deoxy as a measure of overall activation. But I would say the most common measurement for activation in FNIRS is just HBO, just oxygenated hemoglobin. The two are anti-correlated. In my view, you get a sharper response if you subtract the deoxygenated signal from the oxygenated signal.
Yes. Which is the deoxygenated is the one on the lower row.
Yes.
HBR. Yes.
Yeah. So I don't know what else to say about it. FNIRS, the advantage of FNIRS is if you really have strong hypotheses about localization, it's a hemodynamic response. The level of acuity is nowhere near fMRI, but I have more confidence in the localizability of an FNIRS signal as compared to the localizability of a high-density EEG signal that's been subjected to blind source separation.
Interesting.
And
Well,
certainly you can use FNIRS to together with EEG in order to validate your blind source separation, and that's an interesting area.
they tap into different processes.
Yeah, tap into two different processes, and the two brain imaging methods have their own advantages, obviously. And I know people do EEG and fMRI studies. I think that those are really challenging studies to pull off, and you don't see a lot of them. Integrating FNIRS and EEG on the same cap is comparatively quite straightforward. The two signals don't interfere with one another, and each brings its own advantages. So you can use the EEG to look at the time course, to use it as a biometric for band power analysis of interest. If you're trying to localize the source of that neuroelectric activity, FNIRS is a way to validate that localization.
Definitely. Thanks for this overview. It's important to interpret the figures.
Okay, so just a little bit more about our approach. So the playlists are generated in real time by the artificial intelligence, and it is individualized for different classes of users, and we use reinforcement learning in order to optimize the trajectory. So if one path is more effective than another path, it's going to be more likely going forward. We also integrate complementary technologies. So there's an area of research that some of your guests might be familiar with.
Mm-hmm.
It's binaural beats or auditory beat stimulation. So there's some controversy in this literature. There are a lot of claims in what binaural beats can do, but the basic idea is that you're entraining the brain, so you're reinforcing certain endogenous rhythms that are already present in the brain. And in my view, the literature for the ability to use auditory beat stimulation in order to create focus or energy, that literature I think has some question marks, and we need much more work to really understand it. But if you're looking at the ability to use binaural beats to induce calm, I think there's something there. And the way that people think that this works is to entrain in the theta range. So let's say 4 hertz. So you're putting a carrier frequency in one ear. So let's say it's 200 hertz in one ear and then 204 hertz in the other ear. And you get this modulation at the difference between those two at 4 hertz. And that sets up a kind of entrainment that reinforces the 4 hertz rhythms that are already present in the brain. So that's what's happening when you're looking at the brain from a neuroelectric perspective. But when you're looking at this psychologically, what seems to happen is that people feel this sense of calm. So when people are using the calm mode in Lucid, we're putting these two things together. We're using the automatic music recommendation system. That's that AI system that I just explained, but we're also layering in auditory beat stimulation. We're also layering in nature soundscapes. There's a whole literature around the use of soundscapes to induce calm. We're using immersive audio to really have the user feel like they're surrounded by everything. And
it's really interesting. We do have a question from the audience. Hopefully this is a good time.
Yeah, let's take it.
So Alfredo asks, on account of what you said on binaural beats, if they can be detected in the EEG signal, and if can the effect be measured?
Yes, you can detect it in the EEG signal, and it can be measured. Yes, so you can look for an enhancement in if you do a Fourier analysis on the raw EEG, at the frequency of stimulation, you should see that after you've applied the binaural beats, you have more energy at the frequency that you've been trained at. So yes, that's something you can see.
Great answer. Great question from Alfredo.
So yeah, we understand auditory beat stimulation from a neuroelectric point of view, and we understand it from a psychological point of view. You know, if you look at physiological, peripheral physiology, heart rate variability, you ask people how they're feeling. When you stimulate in the theta range, it does seem to calm people down. What happens between the neuroelectric response and the psychological physiological response, I don't know. Like, you know, I have some guesses as to what might be going on, but we don't understand that.
Maybe the key to start understanding, also connected to the next question from the audience, is if you if you were to analyze the effect, the measurable effect in the Fourier transform of this 4 hertz binaural difference beat, where does that localize, right? So I guess it could be primary and secondary auditory cortex, but if there is a traveling wave, what did you observe? What is the general experience? Does the literature say?
Yeah, you know, this broadly falls under rhythmic entrainment, and it's surprising. It certainly, you see the effect in auditory cortex, but you also see it in frontal areas. You see it in the visual cortex, and you know, there's good evidence that auditory rhythmic entrainment will actually entrain the visual system's ability to detect objects at certain points in time. So yeah, it is pervasive. I think that what's happening is that it starts in the auditory cortex, but this rhythm is able to entrain endogenous oscillations in the 4 hertz range wherever they're occurring. That they could be in the visual cortex and in the frontal lobes, auditory areas. Yeah,
makes sense.
So it's really across the brain. It really is. And we've looked at the relative amount of entrainment in motor areas as compared to auditory areas and visual areas, and there's nothing obvious there. Like I see a similar level of entrainment across all of those areas.
Very interesting.
Yeah. Okay, so that's the general approach. I think I've talked enough about the system. I'm going to play an example. So let's pretend that I'm a user and I have now input into the system that I'm feeling like this. I'm feeling kind of somewhere between gloomy and miserable. Okay, it has nothing to do with you, Chris. And I think I said actually I'm feeling positive earlier. So, but let's pretend I'm feeling like that, but I want to feel peaceful. So here's an example of a sequence of tracks. So this is not all done with one track. It's about the sequence. And remember, we're starting with the mood state of the listener and we're bringing them to the target state. So I'm just going to skip through this. This is actually about 25 minutes of music, and obviously we're not going to play that all. Actually, we didn't do a sound check. Can you hear audio?
No, I think it goes through your headphones, but you can maybe disconnect the headphones for a second and play it environmentally.
So I'm going to skip ahead to something closer to dissatisfied or ashamed. So somewhere like this. skip ahead again. So I think now I would characterize the music as being somewhere between pensive and nostalgic. So we're on our way to peaceful. I'll skip ahead again. So I'm very much now getting close to the target. So this is 25 minutes later, right? So you get the idea. I'm going to put my headphones in again. Okay, can you hear me? Okay.
It was very relaxing at the end.
Very good.
Yeah,
okay, hopefully
I can hear you.
You're still awake.
I'm very relaxed now.
Good. Then mission accomplished. So, yeah, of course, this is going to work better for some people than others. We haven't tailored this to your music preferences. This is the standard music that exists in the system, and as you know, it's a kind of ambient, minimalist kind of music with nature soundtracks. But the system will also work with a different library using the same mere features approach. And obviously the AI needs to be trained appropriately so that we can get that customization right. But this is the standard approach we would use. This is the standard kind of music we would use if there was no customization involved. Okay, so when we use this standard approach, what we have found is that the system is more effective than a standard Spotify playlist, a standard, we happen to use Spotify's Calm playlists, but we could have compared it to another system. So there's something about this approach that's more effective. This is a little more rigorous of a study. Here we did a randomized control trial on state anxiety, and we're combining music and auditory beat stimulation, and we find that its ability to reduce anxiety is certainly more effective than our control, which is pink noise, which many people, by the way, use as a means of reducing anxiety. And when we combine ABS and music, that's more effective than either one on its own. And these are two different types of anxiety: somatic anxiety that I feel in my body, and cognitive, which is more about worries. And we seem to have that effect there. Certainly when we compare our full system to pink noise, it's there. How does this compare against other standard approaches to anxiety? It's I think there's many studies that we could look at here, but it seems to be more effective than breathing exercises for a similar amount of time. There are many metrics, many systems of meditation we could have used, but we're pulling this from a meta-analysis of meditation and breathing exercise. We see that the system is at least as effective as that. And this is just from one session. We don't know yet what the system can do in a longitudinal kind of approach. It may not get any better than this. I hope that it does get better than this.
CBT is cognitive behavioral therapy.
Yeah, so ICBT internet-based cognitive behavioral therapy. So cognitive behavioral therapy is kind of the gold standard, empirically supported system for dealing with anxiety and depression. So that's a very tough one to be competing against, but that's 1 week of treatment, and I would. We just don't have the data that it would take to compare to cognitive behavioral therapy, but I think it's even a bit artificial to try to compare this to that kind of approach. I think it makes sense to think about ICBT as attacking the source of the problem, whereas a music intervention like this is best thought of as a kind of treatment to deal with symptoms that manifest themselves. It's possible that this kind of music-based system would have long-term cumulative effects, and it could challenge CBT, but we just don't know that yet.
I guess you should have to try for 1 week with Lucid.
That's on the books. Yeah, with many studies planned, but that's certainly one of them.
Yeah. Awesome.
So I'm almost done here. Other things that people are doing with this system. So we do have some clients that are doing therapy with the system, and what you can do is you can plan the emotional trajectory of a session. So over the course of an hour, you could program the background music to follow a particular trajectory. Or if you're working with psychedelics, let's say, where the person is in more of a compromised state, you may or may not know that psychedelic therapy is on the rise again. It seems to be an attractive option for dealing with treatment resistant mental health conditions. So
I have a question there.
Let me just finish the thought, and I figured there would be questions about this. One of the things that we're doing with a partner, MindCure, is where we've given them this system in the form of a kind of emotional DJ. So the system is there for the therapist to steer the session in a particular way. So they could ramp up the arousal, they could bring it down, they can make the valence more negative or positive by reading the client, reading the session, and moving the mood in the way that they want to move it. Yeah, I'll take the question.
Oh, I believe this you answered already, because I was curious to know how psychedelics administration could be modulating across the different states, emotional states, and you answer. I'm still trying to understand what's the error bars, what's the leeway of any psychedelics therapy on how systematic, how deterministic is the effect of administering psychedelic drug and then seeing a specific emotional shift.
Yeah, I can't really speak to that because we have not yet done research where we look at the effectiveness of different kinds of music playlists during psychedelic treatments. But I can say anecdotally that users that use playlists that conform to a particular profile leave their sessions more satisfied, and they feel like they got more out of the session. And I won't unpack this too much. Like there is, I guess there's some intellectual assets here, but the basic approach is that you use the music to create tension and release, and that becomes fodder or a background that allows the therapist to support the client to get comfortable with their trauma or the tension. And it's the act of getting comfortable with it, coming out of that tension and ending in a state of calm that people find therapeutic. What the mechanisms are in the effectiveness of psychedelic treatments. There's a whole rich area that is beyond lucid, that's beyond my research expertise. I think the way that we'll get involved in researching this is in assessing the interaction between the music and the psychedelic agent. I think the nature of why psychedelics are useful for dealing with treatment-resistant therapy is for another guest that knows more about the molecule and the global brain responses. I do know a little bit. In general, we see this damping down of the default mode network. People say they're more comfortable with themselves, less worried about self-protection. That's something that the molecule seems to do. And, maybe that provides a context with which people can explore memories or feelings that are uncomfortable. And the act of doing so is cathartic and allows them to feel some relief from that tension. I think broadly, that's what people think is going on, but as it's pretty beyond me. And I guess that's as much as I'm comfortable elucidating on there.
I think that's an interesting perspective, because what I understand of treatment-resistant, conditions, this is one of the limitations, for example, of CBT, whereby administering CBTs, you can be effective for a short middle term, but in the long term you have a lot of relapses. And the same with drugs. If you administer drugs, they have a local short-term effect, and then you might be incurring into relapses of anxiety, depression. We're talking mainly, right? Treatment-resistant depression, treatment-resistant anxiety. And one of the pathways that is definitely interesting to explore is using psychedelics, and the other is using brain stimulation, right?
Yeah.
Transcranial electrostimulation, because what does TES and psychedelics have in common? They probably modify the neurochemistry of the brain, right?
Or the coupling within nodes of the brain. Those are different views on the same phenomenon. Yes, the molecule is affecting the neurochemistry, and from a neuroelectric perspective, that's affecting the coupling somehow.
I think the particularly interesting thing here in relation to the framework that you have here, Frank, and the kind of new horizons of psychedelic therapies in psychiatry and neurology and elsewhere is that the actual therapy itself, which is for slower acting compounds, is a guided trip over the course of a few hours.
Yes, it can be 5 hours. Yeah.
So it really lends itself really well to exactly what you're talking about here, as opposed to, for example, like an IV ketamine, which is actually one of the other big new therapies in psychiatry, which is kind of acts within minutes, and I think you're probably out of the clinic within an hour, probably done in 10 minutes essentially. We wouldn't necessarily see an emotional trajectory during an IV ketamine administration.
But having said that,
definitely during a guided trip.
We're actively figuring out what we can do for ketamine clinics as well. And there the approach might be more about readying the client for the session, not so much about what's happening within the session. So if you're about to go into a ketamine session where you're really knocked out by all indications, it's not like psilocybin where you're sort of there, but ketamine, you're really in this vulnerable state. And I gather that if someone has a very tense kind of response immediately before the ketamine kicks in, it can be just a horrible session. So if we can modulate the mood to get someone just where they need to be, then that's another effective use of music in a different kind of psychedelic therapy.
It's really interesting. So it's almost like, John, it's almost about uptake of ketamine or other substances and how they modify. They have long-term, mid-term plasticity effects on those networks. Like, you're almost, allow me to say, to cite the doors. You're opening some doors there to perception, right? Perception and action in this case.
That sounds fair to me. You're again, I'm kind of speculating out beyond what I know. I'm at the edges of what I understand here, but I don't know that anyone really understands, other than there's something effective for treatment-resistant mental health problems. And my read on what I've seen in the literature, the neuroimaging literature, the therapy literature around psilocybin, is that you are opening a door. You're allowing people to deal with, process, experience feelings that are otherwise difficult to deal with. And it's in that reprocessing, that emotional work, that people feel better, and feel better for potentially a very long period of time. For people walk away from psilocybin sessions feeling renewed for months at a time. So there's something a little different going on.
Yeah. I mean, the actually slightly more established intervention in this area is amphetamines, right? MDMA.
Right.
The psychedelics like psilocybin and LSD in the therapeutic space are very new. But
very new, but very old, right?
Very new, but very old, exactly.
Yes.
Like, got banned in the end of the 60s, and but the work on MDMA for various kinds of like working through emotional issues and depression and so on, that I think has been becoming an established approach over the last 5 years.
Yep.
5 to 10 years.
Yeah.
And it's been kind of leading the way in terms of how these the clinical trials are coming together, and how like clinicians and therapists are thinking about, like, what's my reference point here? A lot of the time, like, your reference point for approaching some one of these new, like, psilocybin coming through is like, well, we've seen decent effects in this population with MDMA, with a similar kind of guided trip type intervention, and we'll kind of base things off that and take it from there.
And I think, John, this is not only about the effect. You're always going to see an effect, but the currency, I think, and correct me if I'm wrong, is the decreasing the number of relapses for any treatment resistance condition. And then amphetamines being also one of the drugs, or one of the compounds that taps into these emotional networks, right? That were very well described in terms of features, emotional features of valence and arousal, has the ability, because it has a long uptake time, has the ability in that uptake time to modify the neurochemistry, and hence modify the neuroelectric compliance, and then coupling of the different networks, if I am not wrong. And then that has a long-term effect, as opposed to CBT, cognitive behavioral therapy, that doesn't have that direct uptake of a drug that modifies the neurochemistry of the brain, and hence is able to modify the plasticity of synapses, and hence qualify for a long-term effect, and hence qualify for absence of relapses.
Yeah, I'm not comfortable endorsing that CBT is a temporary fix, and that psychedelic treatments induce real neuroplasticity that leads to long-term effects. I think there's different routes to long-term therapeutic effects. But what I would endorse from what you've said, Chris, is that certain drug approaches, so for example, the use of benzodiazepines in order to regulate agitated states in psychiatric wards, increasingly in long-term care facilities, all sorts of bizarre uses, that has very temporary effects, and there's all kinds of side effects, and it's dangerous. And if we can use music instead, we should.
Understood. That's clear.
Yeah.
Uh,
Yeah, I know. I'm a believer in CBT, and I don't think it's fair to say that it can't have long-term effects. But for certain folks, it has its limits.
Understood. And that's the data speaking. It's not only us.
Yes, yes, that's right. Okay,
I have a question.
I'm gonna. Okay, yeah, I'll take another question and then I'll wrap up the presentation, and then I'm happy to talk more broadly. Yeah, go ahead.
Sure. I was wondering about the emotional trajectory with the music that you played, the 25 minutes of music that you
Yeah,
played before,
yeah,
in small intervals. It strikes me that there is no singing, there is no language
yeah,
component, speech component.
yeah.
Is that something that is done on by design?
It is done by design. The voice tends to draw attention, and it tends to um, lead to highly variable effects. So um, we intentionally steer clear of the voice. So it's hard for us not to pay attention to music with voices, and I think the way that we process the music once it has lyrics and voices is a little different. It becomes the focus of our attention, and we're trying to understand it in a very concrete kind of way. And uh, the music doesn't have the same potential to sneak up on us and capture uh, capture us and pull us to a different kind of emotion. Um, that's my belief. Um, um, we just see highly variable responses in emotion once voices are introduced. They can be very
Understood.
effective, but the response is quite variable.
I understand.
So
Thanks.
yeah, yeah, yeah. It's hard to ignore the human voice for evolutionary reasons, I'm sure. Okay, so my synopsis is that a transdisciplinary approach that blends methods from music therapy, music psychology, music informatics, all wrapped in this machine learning shell, seems to be effective in creating functional music playlists for emotion regulation. Our RCT demonstrates efficacy that compares with leading pharmaceutical and behavioral interventions in people living with moderate trait anxiety. While all of this is promising, the potential of this approach needs to be assessed longitudinally and with additional outcome measures across diverse populations. So that's what we've been up to at Lucid. Here are some references for people that want to dig into some of the details of the music informatics work, the emotion work, um, the music psychology work, the music therapy work. And you can find more information about the Lucid project there. My lab, Smart Lab, at smartlaboratory.org, and that's my Twitter handle. So if there are more questions, I would love to chat a bit more about Lucid or anything else that you're curious about, that you've seen about my lab. I'm happy to zoom out as well if that's of interest.
I thank you, Frank, for this incredible presentation. I love the content and I learned so much from it. And I have to say the truth. I was looking at your project before. We were in touch before. I've always been interested in the Lucid project. And during this conversation that we are having tonight, I was mentioning depression. I know that you mentioned anxiety, and the natural question that comes to mind is if the lucid methodology is as effective to shift emotional states in treatment-resistant depression, for example.
Yeah, we don't know yet. We haven't done a study. Um, we know from our user base. So Lucid exists in different forms. There's an app, and it's in all of the online places, but it's also an API that is used by digital therapy companies. So psychedelic companies like MindCure, but also traditional therapy companies, and I gather that some of the clients are living with depression, but we haven't done a formal study of depression yet.
Thank you for taking this question. I have one question from the audience. Richard Waltman from OpenBCI asks, what are your thoughts on the implication of anti-music noise music? He mentions John Cage.
Okay, John Cage and anti-noise music.
Anti-music noise music.
Can you say a little bit more about what you mean? Like, I'm certainly familiar with, all the strange and wonderful experiments John Cage was involved with as a composer, but I don't know what you might be getting at here.
I would have to ask Richard if you would like to come on screen.
Great.
Have you ever played on a prepared piano?
Potentially. Richard, you can answer, let's have you on screen.
Prepared piano is a piano that has like little things stuck on but the strings that random.
Yeah.
So you get this
Richard.
weird combination of the tones and these percussive interruptions that are from those things that you stick in it.
Yeah.
John Cage.
Hello. Can y'all hear me okay?
Yes.
Yeah, I can. Yeah.
Absolutely wonderful stuff.
Cool.
I had a hunch a few years ago that this was possible, and I just want to start by commending you that y'all truly done this the right way.
Awesome.
And it's
awesome.
really, and I said in the chat, music.
We believe in the approach. Like, I'm sure it could be made better, but it works. Like, it seems intuitive, and there's theory to back it. Thank you.
So
go ahead.
What I mean about my question is, you want to do an emotional DJ. You're using all these wonderful tools. I read in the science part of Lucid that y'all are even doing some analysis on the music that you'd like to do, like getting the key, matching other different aspects of the music, which is really hard in itself.
Yeah, well, that's some of the scraping of the mere features. It's definitely hard. Key is not, there can be mistakes, but, the mirror community, I don't know if you're in the mirror community, but, that these are very active questions. How do we get at more musically realistic kind of data, not things like low frequency energy or roughness, but rather, things like key or amount of modulations, harmonic progressions. Yeah.
But I also have a familiarity with a genre of music called new music, and thinking about music that was made after 1950. And another notable composer is Caroline Stockhausen. And if you put Caroline Stockhausen with most of your participants right now, they probably wouldn't like it, and it would move them backwards in the graph to a more negative.
Yeah, I think they'd move towards anxious states. Yeah, that's fair.
So, what role does
unless you gave them months of exposure to Stockhausen and Webern and whoever else you want to throw in there?
Stockhausen therapy.
Stockhausen therapy. I guess I'm going on a tangent there, but I think that if you're not familiar with that kind of music that doesn't use conventional tonality and that tries to break all the rules, you're going to be led towards a negative affect. But I think it's also, people have done experiments with atonal music to see if you can convey emotion within an atonal framework, and you can for people that are experienced with that kind of music. Like you can, even if you listen to death metal. So I have a colleague in Australia that.
What I mean by noise music.
Yeah, so he wondered, like, all of this music sounds super angry and violent. does it sound this way to the people that are consuming it? And of course it doesn't. But he's shown empirically that no, you can slice and dice this music and come up with an emotional matrix. So exposure certainly plays a huge role in the way that we read music emotion. There are generic principles, but humans are super flexible, and I guess we can attune to different systems.
Thanks for this question. And Richard, you're welcome to stay on video if you like.
I'd like to mention, it seems like the system that you've developed accounts for that. Because since you said people could already bring their own playlist. So the guy that likes death metal, which is like, it's in the genre of noise music, like blast beats, they would already be happy to hear that. And that's wonderful.
Yeah, we need more death metal listeners. We need to train the system on more death metal listeners to make it all work really well. And that's, But the approach can do a couple of things. Like, we can consume music from your playlist and just use the AI that we've already trained that's closest to your genre of interest in order to categorize it in our grid. But if we get enough data from people that like reggae, who like rap, then we can start to create curated playlists for that class of users. And as we amass more users certainly through our app, that's some of what we're trying to do. That
Play with different genres, having the touch point with the current Spotify playlist, and then leveraging that reservoir of songs that comes from the direct experience of the users, maybe with real songs, right? I have a question. There's a question from the audience.
Totally doable. So, for example, we worked with Apple Music. We worked with one of their artists who was Rosie Chan in the UK. She does pretty traditional kind of classical filmic music, but she calls it functional music, and we actually worked with her and ran all of her tracks through our AI and gave her these emotional trajectories. And the whole idea was, can we work iteratively with the artist to help them get to the functional goals that they want to get to? That was a fun project.
We do have I have a question about tone deaf people. So whereby, you don't have the access point, they don't perceive the modulations, or they don't have even relative pitch. And then there is a question from the audience. So, but because it's a nice segue from what you're saying now, I just stuck in my question here.
Yeah. Okay. Tone deafness is something that's near and dear to me. I worked really closely with a journalist author named Tim Falconer, who's he is tone deaf, and he went to see music neuroscientists around the world, and in an effort to understand more about his condition and understand what tone deafness is. And he wrote a great book called Bad Singer. Anyway, what I'd say about tone deafness is that it's greatly exaggerated in popular culture. People think that they're tone deaf. They think their sister's tone deaf. And, they think that it's like at least 10-20% of the population. It's really about 2 or 3% of the population that's truly tone deaf, who cannot match a pitch. So I play a pitch and I ask you to sing it. You can't do it. I could say more about the sociocultural reasons for why people think they're tone deaf, but there's a really low incidence of tone deafness, and what's going on in the brain in tone deaf people. It seems that the hardware, the connective tissue from auditory cortex to motor planning areas is not as well developed. So we get thinner fiber tracks in the arcuate fasciculus,
Wow.
specifically in tone deaf individuals, and you get it more. There is some variability in the literature, but you get it more in the right arcuate fasciculus than the left. So tone deafness presents in different ways. It's exceedingly rare. There is a genetic basis for it. But even with tone deaf individuals, like my friend Tim Falconer, he gets music. He loves music. We've gone to concerts together. He could tell you about why he likes the music that he likes. He's just not tuning in to the pitch details. He gets all of the textural details, all of the rhythm. And the emotion in music is highly redundant in most music forms. It's, you know, you're conveying the emotion through the rhythmic aspects, through the amplitude modulations, the dynamics. So even the tone deaf people could use this kind of system, I would say. We haven't tested that, but it's too niche. But
Dr. Russo, your understanding of music is your understanding of music is quite comprehensive.
Okay.
It is true that you can modulate all these different aspects of music to convey emotions, and then even do different ones. And then on the other side of the tone deafness, I just want to point out the type of people that I met in music school, which are perfect pitch. And I was a little worried earlier when you said doing the binaural thing. It might actually hurt people like that. Like it hurts them like deep down.
It might. You're right. No, that's. I don't know what the percentage of people with perfect pitch is. I wonder if it's higher than people.
I think it's like a bell curve. So I would expect, there's plenty of people in the middle with varying degrees of aptitude, and then on the other side is, a very small percentage.
Might be another 2-3%. But that group could be annoyed by something like binaural beats. We don't have this in the system yet, but I guess one solution for that would be able to turn on and off the different aspects of the system. Just flip off the binaural beats. There is another piece of technology in this system. I don't want to make this like a sales pitch, but we've tried to tamp down the presence of the binaural beats, because a lot of people find it annoying, not just people who if you just hear this constant drone, if that's all you hear and you're ready to focus on that, that's one thing, but it's there, but you'd rather listen to the music, you might find it annoying. So we do have a patent on a system that masks that binaural beat. So we do that by tuning into that frequency in the music and the harmonics of that frequency, and through filters on the spectrum of the music, we're masking that binaural beat. So it's not as prominent as, it's not as consciously prominent as it would be if we just let it hang out there.
As a bandpass filter.
Yeah. So it's putting a filter on the whole spectrum of the music. So we're not erasing the binaural beat, but we're trying to take some of that edge off.
Understood. I do have a couple of questions from the audience, if you like, Frank. And one is, I would like to go by, when they were asked. So Alfredo was asking, I guess, to connect it with the previous, topic of, let's say, modulation without speech, and how many features are present in the music that account for emotion, rhythm, keys, but also key modulation, loudness. And he's asking a question about, on the other side, about speech prosody, which is a kind of modulation above the, the loudness of speech, or the pitch of speech, that is overly present in singing, but it is also present during utterance of sentences. So can you talk about speech prosody as interventional treatment in relation to trauma?
Oh, wow. No, I don't think I can. But Yeah, certainly I could say a little bit about speech emotion. I can't, I mean, there might be therapies that involve speech emotion, but I'm not really, I'm not versed in them. I can say something about our own use of speech emotion in therapy. So I don't think I'm answering the question, but let me just say a few things. One, yes, prosody can involve fluctuations in the loudness of the voice, in where I place my stresses, in the timing, in the harshness of my voice. All of this conveys so much emotion, for sure. And there are systems in the brain that process that emotion. I think there's two dominant systems. One is more mapping sensation onto action, and the other one is more cognitive. One of the therapies that that I've been involved with that really it's quite experimental, and it really hasn't taken off. Doing this kind of intervention research is really challenging. Most of my work is done in the lab. It's very clean. I look for changes in the brain or in people's mood, and they go home and I take their data and I publish it. But if you're trying to have an effect on people's well-being, it's really challenging to do. So I think that one way in which you could use emotions in speaking or in singing in order to support well-being is to take people who have some interruption in their ability to process emotion, so some disruption. And a few examples I'll mention are autism spectrum disorder and Parkinson's disease. And I'll throw in another one, and these things sound like they have nothing to do with each other. Autism, Parkinson's disease, and hearing loss. What do they have in common? They all affect our ability to process emotion, to understand emotion through the voice, and to communicate that emotion. So the way I think about this is that one of the main ways in which we read other people's vocal emotions is by taking the sounds of someone else's voice and mapping them onto a motor program that leads to associations for how we felt when we expressed ourselves in the same way. So if someone's angry and I hear that in the voice and I'm trying to understand what they're feeling, then I'm simulating that anger and I'm feeling it myself. So if I've got an interruption to my sensory system because I can't quite hear all of that anger, I can't separate it from fear, there's some filter that's preventing me from doing this. Or if I have a motor problem like Parkinson's disease and I can't execute the motor plans for fluidly expressing emotion, then I have some difficulty in reading other people's emotion. And this is speculative, but people have characterized autism as a connection disorder and as some kind of interruption between the perception and action. So that's the way in which all these three systems are linked. And in all cases, we've been experimenting with using emotional communication as a kind of treatment. So none of this work has really seen the light of day in terms of peer-reviewed work, but we've put a lot of effort in, and we've seen successes. So in Parkinson's disease, I founded, I co-founded a nonprofit called Singing with Parkinson's. It still lives today. In pre-pandemic times, they were rehearsing at the Canadian Opera Company. The way that this choir came to be is that we had this hypothesis that people with Parkinson's disease had difficulty understanding other people's emotions, and at the root of this was the motor deficit. So we tried to characterize the motor deficit and used it to predict the extent of emotion communication disability. and that work is published. That work is out, and there's a little cottage industry now of people looking at Parkinson's and emotion deficits. I think that was one of the pioneering papers. But at the same time, what we really wanted to do with these folks is show that there was an emotion deficit that was linked to the motor problems, and to see if we could train some capacity in emotional fluency by practicing emotional singing. And the logic here is that it becomes easier to move in the context of rhythm and in the context of song, and it maybe becomes easier to imitate someone else's emotions in the context of song. So we hired a choir director that spent all her time, well, she didn't want to do this, but we kind of forced her to coach the choir into singing, singing very happy songs, very sad songs, and getting people to really feel that emotion. That work may see the light of day, but it hasn't yet. And what we've seen in that work is that people are more fluid in their expression of emotions. What we're about to publish is vocal benefits of the singing, which are not that novel. Other groups have shown it, but we've really needed to collect more and more data to get at this comparatively weak effect of strengthening capacity for understanding emotion by practicing emotional expression. And we now have this network called Singwell Canada that we've got partners around the country and around the world now. It's a very large SSHRC grant. It's one of these partner grants. There are 50 partners. It's 7 years. And one of the objectives is to collect enough data with all our partners to see this thing through, to show the benefits of rehabilitating emotional communication capacity through emotional singing. We've done something similar with autism spectrum disorder. Again, there's no paper. Data comes very slowly. But we ran camps at Ryerson. We ran camps for 4 years in partnership with the Geneva Center, where we bring kids in and we have them practice emotional singing. There are some trends there, but there's so much noise in the data. So that didn't answer your question. I really went on a whole long time, but I think that what I would call all of this is imitation therapy, that by imitating someone else's emotional expression, we rehabilitate the circuits that are involved in processing emotion. That's the belief.
And I like your example on, and thank you for this articulate answer on all your projects. I added a link to Singwell Canada here in the text chat.
Thank you.
For people to have a look at. And I'd like to reconnect, and then I have another interesting question from Alfredo. I'd like to reconnect to Parkinson's and motor planning and stuttering, right? We know the movie The King's Speech and how
Absolutely.
The problem with The King's Speech was resolved in the movie. And, it almost closes the loop. You need to close the loop to have the, the feedback between your action and perception loop, in fact. Whether that is outside or inside the brain, you need to close that loop to be able to have a feedback, on your motor actions or your motor perceptions. And in one way, in Parkinson's, might be a lack of, perceptual input, and the other might be a lack of feedback on your motor input. And that connects to a question from Alfredo that asks if you can comment on the use of audio to help with Alzheimer's patients.
Oh, well, there's a lot of excitement about using music and a lot of positive evidence of the use of music in treatment of Alzheimer's. We've got a lot of work to do, but what I can say is that music can be used to manage agitation. There's some evidence of that. And there's some evidence of music inducing these lucid moments. I think it's very temporary. That's my belief.
It depends on the stage.
It does probably depends on the stage, but certainly these, you know, my father is living with dementia, and I've known other people living with dementia. It's very valuable to have these moments of lucidity. So even if it is temporary, this is a meaningful effect, because what this means is that for the minutes following the music, you're better able to engage the person living with dementia than you were before then. But yeah, treatment of agitation, that's in lucid sites as well. So we have a partner in Japan who's essentially hired us to develop a system for managing dementia through music. And the idea, the long-term idea here is, can we use biometrics in order to read how the patients are doing, and can we serve up music in a way that reliably mitigates this agitation or creates these lucid moments? Can we use something about the biosignals to fine-tune the system? So we can't necessarily ask them, do they like this, or did it mitigate their mood, but can we use biometrics to steer the system like that? I'm sure other groups are working on this kind of thing. I think it's a super exciting project, and there'll be valuable outcomes.
Or biometrics, like accelerometers, because in that, you know, you're talking about, you know, the stages of dementia that are quite advanced when they have agitation, because they are probably not aware of their surroundings as patients, and they have, you know, blurs of, you know, aggressive behavior, and you know, that's part of the you know, how dementia works. And but in terms of biometrics, what do you acquire? The movement, the skin galvanic reaction.
Yeah, we're going to throw the kitchen sink at it, but the candidates that we're interested in are using video-based analysis of affect. So there, you know, there's a lot of good work already. We don't have to invent anything there. Using vocal analysis. And I don't know if the form factor will be something that is meaningful or not, but using EEG is certainly something that we want to look at. So, you know, I don't know if that's a realistic solution, but it's something we're going to explore as well. So trying to characterize different mood states on the basis of these biometrics. And I'm not sure where all of this will manifest, but you know, I guess one outcome is if you can have biometrics that reliably anticipate these agitated states, then you could trigger music to guide someone into a more relaxed state without needing to use something like Haldol or benzodiazepine, which is increasingly common. We have had a ridiculous uptick in the use of these kinds of off-script uses of medication in long-term care facilities during the pandemic. If we could use music increasingly to steer people in the right direction, that would be excellent. But again, another indication is lucidity, and seeing if we could cultivate these moments of lucidity with music.
And thanks for doing that.
We can, but can we optimize it? Yeah, thank you.
First of all, thanks for doing that, and for mentioning the systemic biases of the medical system, or alluding to them, and secondly,
I'm not that balanced when it comes to that. I have some strong opinions that
rightly so.
Yeah, I think there are some real abuses of pharmaceutical agents that are essentially handcuffs. They're chemical kind of restraints that they're easy to use, but there are repercussions for quality of life, for sure.
Yes, and then we mentioned during this event that approaches to the end, we mentioned that there are different kinds of molecules, compounds that can be administered with side effects or without side effects, and the more natural they are, the least side effects they have. And we spoke about psychedelics, and most of the drugs or molecules that are administered, they have a natural basis. I don't know about amphetamines. I guess they are synthesized, but is it a rule of thumb to say that everything that has quick clearance and is synthesized in the lab and with proven side effects is probably has to be reconsidered?
Yes, I think that if there are known side effects and we have alternatives that are equally effective, we need to do more research and increase public awareness. I think there's a cultural undoing that's necessary within the medical community, and I think it's a long road, and we need a lot of really good research from a lot of independent groups to convince people that these non-pharmaceutical approaches are valuable. Yeah.
Yeah.
So I mentioned something in the chat. I heard a talk at AWE from a company called EmoShape. They're doing the other way around. They're trying to synthesize emotions and then have, like, instead of Siri saying something very flat, add inflection to the words and whatnot. But the way they arrived at that is they spent many years looking at the face. They had not even considered EEG. Did Lucid consider looking at participants' faces and maybe using facial emotion tracking and then correlating that?
Yeah, as an input, using the camera, for example, of your phone or something. Yeah.
Yeah, because currently we can feed pictures
Absolutely.
to like Azure, AWS, and I think you can get basically if a person is happy or sad, how they look at your product.
Yeah. There's a few really good APIs that do that effectively, and so we've played with that at Lucid, and we've chosen not to pursue it currently for our current indications. I think we will come back to it with dementia. We did use Affectiva. It's a MIT-based company that does this facial affect classification. We used it in Emote Play, which is another company that I have a long history with. So we developed this system for training emotion in children through imitation. It's an emotional imitation game. I never got around to speaking about it, but it exists on the App Store. It's emoteplay.com, and the main app is Big Break, the Big Break game. And what we do is we have the child imitate emotions that are displayed by actors, and it's in this fun Hollywood. There's many Hollywood studios. It's all gamified. You win gems, all that kind of business. But what we do is we read the child's face and we give them back a score for how well they've imitated the actor. So we record the voice, and we can compare the fundamental frequency pattern of the child's voice to the actor's voice, and we can come up with a correlation index, and we can use the affectiva on the actor and on the child, and we could look at how well they mesh, and we can give the child an imitation score. And as they get better at that imitation, they win more gems, the levels get harder. That's the idea. Yeah.
It's very interesting. Yeah, I wanted to thank everybody. Frank, for your fantastic contribution. We learned so much from you today and about your work and then the Lucid project, and the good that you're doing for the community as well. So congratulations for your business model, and all the guests, all the people that came and made questions to you, including us. And I hope you had fun. And then thanks for your contribution.
Yeah, you kept me dancing. That's lots of Good questions and food for thought. Thank you so much for inviting me.
It has been a pleasure for everyone. But stay tuned, because in 3 weeks, we have our last episode of this second season, NeuroTechX Showcases. We will have Vox Neuro representative, Douglas Martin, 8th of December, here on NeuroTechX Showcase. And with that, I would like to wish you a very good night.